Hello, how you guys doing? Welcome back. We're coding a Zelda 3-like game again, as always, and I hope you guys getting a lot out of it. I'm getting a good feedback from you, so this is very cool. I'm really happy that you enjoy it. So let's start off as always by showing off where we currently are, and then talk a little bit about what we are going to do today. So first of all, last week the week before we implemented this grab animation. So when we grab an item now, there's some feedback to it. And last week we added these bats here that just follow you and then kick you around a little bit. They're pretty cool. But we cannot kill them yet, which is something... Oh, and there's a bug as well. When I get hit and I attack them, something gets screwed up, so we have to fix that. It's good to know that there's a bug there. But yeah, so we have these bats in here, in our first enemy types. And we also have a shield here. And last week I told you that I wanted to work a little bit on something during the week, just to progress a little faster, because I thought it would be quite similar to what we already did, so it wouldn't be as interesting to do on stream. So the idea was that we have our sword attached to our character, and I want to do the same with the shield. And I thought, well, it's basically the same system because we already did it with the sword, it shouldn't be a big deal. But then I ended up, it ended up not being the same system at all. It ended up being a quite complex problem. And I show you because when we grab the shields, I mean, it works now, and I want to explain what I did, but it took me quite a while and I had to figure some stuff out there. So I'm just going to explain what I did, and so I'm sorry that I don't have the actual creation of this part on stream, but it's mostly similar to what we did with the sword, but there are some differences here, because the shield, as you can see, is whenever I turn, the shield is also it also turns. It has different directions. So we have a sideways sprite here, we have a forward sprite, it's on the back here, and then also when we attack, the shield actually changes the direction depending on the animation frame. So hopefully you can see that on stream. It starts out in the back here and then moves to the front again. And here I think it's easiest to see here in this, if I attack upwards, it starts out in the side view and then slowly goes forward as the animation progresses. And that is something that took me a little bit to figure out, but I'm going to show you how I did that. And something else that this system has is, maybe you can see it, I'm not sure, the arm here, it's easiest to see in the walking right animation. The arm is fixed now. The arm is basically holding the shield. And if we don't have the shield, let me restart the game here. If we don't have the shield, the arm is walking. So it's swinging with a walk. So that is something that was an interesting problem to figure out, and also to make it easy to maintain. So there was quite a few, well, the problems were not really interesting, it was just some finicky stuff that I had to figure out. So I'm still glad that I prepared this, and now I can basically just explain to you guys how this effect was created. So as you can see, if I walk to the right here and I don't have a shield, the arm is swinging, and then when I get the shield and move to the right again, the arm is stationary. And this is basically just done with the sprite swap, because we have those animations. We have the walking animation with the arm resting and with the arm swinging. So we had to tell the animator which one to show, basically, which is it's not too hard to do, but yeah, it's just something we had to work with. So basically that's the state that we're at right now. So yeah, we can swing the sword. We have our shield attached as well. And today I wanted to talk a little bit about. Well, first of all, I will start off with the shield stuff, what I did there, and then I want to implement so that we can attack the bat here and fight back, because right now only the bat can push us around a little bit. And we also have a cool depth particle animation for that. So let me see if I have it here somewhere. Effects. No, it's only bush leaves. I have to create that still. But in the sprites we have the effect sprite for the enemy death here. Can I just drag that here? Nope, I can't. So we have. Let me open this up quickly. We have a particle effect for when enemies die, and I want to add that as well. So it's basically just a slashing animation and then a small poof effect. So yeah, we want to add that today as well. And then if we have time in the end, as our third topic, we can do some GUI stuff, because we have some loot that the enemies can drop when we kill them. This was the wrong folder. Here we have the classic Zelda rupees. Let me show you these, and they have a small light effect on them. So we have some rupees, so we can make the enemies drop them, and then make a small make some GUI that we can show how many rupees we have, and maybe even how much health we have and stuff like that. So yeah. Oh, hello. Do you stream side projects on this channel? What do you mean by side projects? Right now it's basically only this Zelda project. So we'll see where it goes. Maybe in the future I want to do some other stuff as well, but this is the main project right now. And I agree with you, the sprites look really cool. They were created by a friend of mine called Jessica, and she's amazing. And each week she gives us new cool art to work with. Okay, so let's start with the what I did for the shield. Let me refocus this here. So first of all, I mean the first part of the problem was actually quite similar to what we did with the sword. Let me close this and show you the hierarchy that we have for our character. We already last week on stream we basically created different parents here. We have a weapon parent now for the sword, and we can animate these objects. So the weapon parent for the sword shows the sword here, and then you see that the sword is now attached to the weapon parent. And the same happens with the shield. Let me go over there and get the shield. And there you go. Now the shield is attached, and it's attached to the shield parent. So that part is the same as the sword. And let's go over to that code so we can see what we did there. When we open a chest in the interactable chest here, basically what we do, we can set in the properties of the chest, we can set what item is in the chest and how many what's the amount of the items in there. So we have the chest right now that has a shield, and the sword is basically also a chest, just with a sword sprite. And then we add the item to our inventory when we open the chest. And what happens when we what happens here is if the amount is greater than 0 that we are adding to our inventory, we basically look for the item data in our database for this item type, and then check a couple of different things. So first of all, we check if this item has a pickup animation. So when we pick it up, does it have the one-handed animation, which is for the sword, or the two-handed animation, which is basically for any other object. And then we also have an is equipable property that can be, so that we can set to, is the item not equipable, is it equipable to the sword hand, or is it equipable to the shield hand? And the shield hand, this is what I added basically during the week. So you can see here the code is quite similar. If we attach it to the sword hand, we call the equip weapon method. If it's equipable to the shield hand, we call the equip shield method. Thank you for the help, by the way. I was the guy. Yeah, sure. I know. We talked last week. Awesome. I'm glad it worked. Do you have a screenshot or something? I'd like to see it. Oh yeah. Anyway, so we have the equip weapon and equip shield, and since they're doing pretty much the same thing with just a few varieties, I created a new method that they both called equip item, and then in the equip item, we have a couple of parameters. Basically, so the first parameter is basically just saying which item we equip. Then we telling the method to which position we equip it, and the options are again the sword hand or the shield hand. Then we have the parent that we attach the object to. So we have a weapon parent and the shield parent, which are basically those two here, so the weapon parent and the shield parent. And then we have a reference to I mean, this is actually, we have to do this way. So, and then we have a reference to a private variable that we want to set so that we always know which weapon is attached at this very moment. And then basically we just check a bunch of things if the item is this is the correct item to attach, and then we create the item and attach it to the parent that we specified. So this is pretty standard, and this is what we did with the sword before. I just expanded it out so we can use the same code for the shield as well. The interesting part for the shield now is the changing of the sprites depending on where we are. So when we walk left, walk to the side, the shield looks to the side. When we walk down, the shield is in front, and then it's in the back here. It is a similar system to what we did with the sword. So let's check that. So basically what we did, we created in the animations of our character, we can set up some metadata here. Let's go over to the. So the oh no, I'm wrong. It's not in the animation. But so what we did in the animations with the move right. So we created new animations that has. So we have move right. Let's see, up here we have move right, left, up and down, and then we have the same thing for move right shield, move left shield, move up shield, and move down shield, which is basically just the same animation, just the right hand is always sticking up so it holds the shield. And then we have the same for idle as well. So let's go to the code. The code is pretty simple. The shield itself has a component attached to it. So let's go to the prefab here. The shield prefab has armor shield view component attached to it. And this component has reference to all the different versions of the shield, the front side, the back side, and all of that. So what we do in the armor shield view is we are getting a reference to the movement view of our character. And since we're attach the shield to the shield parent here, basically we can call call the method getComponentInParent, which looks for any occurrence of the component in any of the hierarchy here. So it looks in visuals first. There's no occurrence of the character movement view, so it goes to the next parent, and then we have the character movement view here. So we get a reference to that. So we are in the armor shield view right now, and this is basically the armor shield view is a component that is attached to the shield. And yeah, so we got the reference to the movement view of our character. And then in the update method, what we do is simply we get the direction, the facing direction of our character. So in which direction is our character sprite looking, and then we just check if it's looking to the left. So if x is -1, then we set the shield direction to left. We do the same to right, front, and back. And then this method is pretty straightforward as well. It basically just checks the direction, which is an enum in this case, and then basically just swaps out the sprites to. So in case the enum is set to front, we use the visuals front sprite. If it's set to back, we use the visuals back sprite, and so on. And then for left, we basically use the side sprite just swapped around, so we don't have to use a left and a right one. I don't have to create a left and a right one, we just swap it. And this is basically how the shield works, the simplest, in the simplest form. It basically checks every frame which direction are we facing, and then we're setting the direction as well. But now comes the interesting part. When we're attacking with the shield, we want to let me get the shield here quickly. We want to show it to a different position. So when we are moving with the shield, it's pretty straightforward. But if we're attacking, let's attack to the right. You see the shield is displayed in its front position, because basically the character is slashing and the other arm is moving to the side. And it's the same with all the animations. So if we slash down, the shield goes to the left, and it goes to the right when we slash up and stuff like that. So how did we do that? Let's go to our animation events, and this is we used a method that we also utilized with the sword before, and this is animation events. So let's go to an attack event here, and then you see a couple of different events here. And the new event that I created is, oops, attack right is not good for this. There you go. So the new event that I created is set shield direction, and it expects a string, so I can say basically the enum values. So it's front, back, left, right, and also half front and half back, which is which we use in the attack animation. It just makes it a little bigger. So half is basically just at a 45-degree angle. I can show you the item sprite for that. And it makes the attack animation look a little smoother. So let's go to the Explorer here, and I can make these extra large. No, I can't. So you see the sprite front here, and then the half profile front is basically just tilted 45-degree angle. It's not quite the side angle, it's in between. And the same for the half profile back. And maybe I can pause on where we are using this sprite so you can see. There you go, that worked perfectly. So you can see here in the attack down animation, we are using the half profile back shield basically, because it's a little bit further back here when we are attacking. It just looks a little smoother. So we're using the event set shield direction for that, right? But also we want to set the shield direction in the very first frame, you can see it here, because we are still looking down, and when we go into the attack animation, the very first frame, which is displayed right here, the shield is already in the half profile back state. But as we learned 2 weeks ago, Unity has a bug in the animation system, so we cannot use multiple events on the same frame. And also, the problem is that we can only have one parameter for the functions here. So if I add another parameter to this set shield direction method, then I wouldn't be able to use it here in the function, because Unity just has these basic functions that either have no parameters, one int, one string, or one float. These are the options that you have. Or one interesting option is, and you saw it at the top here, is you can also use the parameter animation event. And let me open the animation event here. An animation event is basically the structure of, do you want to show me what it is? A structure with 4 different types in there. So you have a float, you have an int, you have a string, and you have an object. So you can pass 4 different parameters into that. It's still very limited because you can only have one float, one int, one string, and one object. But it's better than nothing. And I basically changed our onAttackStarted method. Before, it basically just got an integer for the sorting order of the sort. But now it gets an animation event, because then we can use the string for the shield as well. Right? So let's go to that method, onAttackStarted, which is in the animation listener of our character. onAttackStarted, it takes an animation event, as we discussed before, and then basically for the set sorting order of weapon, we using the int parameter of the animation event, and then for the set shield direction, we're using the string parameter. And that is also the reason why I used the string for this set shield direction method, so I can have both. I can address both with the animation event. So that was I had to figure that out, but that works pretty well. And well, it has to be in play mode to trigger the events, but anyway. Okay, and then the last interesting thing that we did with the animation system is the part that a different sprite is a walking sprite is used if you have the shield or not. Again, if we walk to the right and we don't have a shield, the arm is swinging, and if we grab the shield, the arm is not swinging anymore. At least not as strongly as when we walk to the left with the left arm, right? So he's holding the shield up at all times. And this is done by using something. So this made the state machine quite complex, because I added a parameter called hasShield, and if it's true, we're using the one sprite. If it's false, we're using the other one. But our base animator is already quite complex, so we want to simplify it a little bit. And as you can see, it looks basically the same as it did before, and there's no mentioning of the hasShield stuff in there. But you can also see that the walk and the idle states have a different shape than the other states. And this is because there is a substate machine. There's stuff in there. It's not just this one animation. So let's go into the idle state and see what's going on. You can see here, basically, it's a very simple one. We don't need those two, disregard them. Basically, the entry means when we go into the state, this is where we're coming from. We can go 2 different paths. So we can check. The bottom path basically has a condition, hasShield is true, and if this condition is met, so if the parameter hasShield is set to true, then we go into the idle shield state, which is basically the state where we're holding up the shield. And if the parameter is false, so you can see here the yellow arrow is basically this is the path we go when all the other paths fail, so if we don't meet the conditions of any of the other paths. So basically the only condition is has shield is true. So if has shield is false, then we go to the regular idle state. And then we switch between them if the has shield parameter changes while we're in idle. And then if the is moving parameter is true, so if we're not in idle anymore, then we exit this state and go over to the walk substate. And we did the same thing in the walk substate as well. So we have the entry here, we check if has shield is true or not, so we're using the walk or the walk shield animation, and we exit back out if we're not moving again. So this made our state tree, blend tree, or state machine, the animation state machine, a little bit more complex, but since we can use the substate machines, it still looks as clean as before. And this is how the shield system works. That's basically it. It was a little bit more complex than I anticipated, but it works pretty well. And so we can basically go on and start coding some stuff again. Oh no, I messed up the text here. So let me fix this quickly. Alright, so the first thing that I want to do today is, so I explained the shield attachment. Let's strike that. The first thing that we actually want to code today is we want to fight the bats. So the bats right now can attack us. Well, they don't really hurt us, they just push us back, but we want to be able to fight back. So basically when I don't have the sword right now. So when I have the sword, when I attack the bat, I want to be able to kill it. So we already have some code that checks when if we hit something, because we can attack the bushes here before. So let's check how we did the bushes, and then maybe we can reuse that stuff. On the bush, we have a component called attackable bush. And this sounds promising because then we can basically create an attackable bat and then add this to the bat. So the attackable is set up in a way, so the attackable base class basically has just the onHit method here, and it's just the interface for, and the sword itself is doing all the work for that actually. So let me go back to the sword item. On the sword, you can see we have a collider, which is, let's put the sword here. We have a collider set up, which basically the hit area, if this is so if this is a collider, so anything hits the sword, then we get the events back, and then we have the weapon collider as well. And then the weapon collider has a method called onTriggerEnter2D. So the box collider on the weapon itself is a trigger, and it triggers the onTriggerEnter2D method if it hits anything. Then we are looking for an attackable component. And if the objects that we're hitting has an attackable component, then we're calling the onHit here. The cool part about this is the attackable base basically has an empty method here, a virtual empty method. And that means that a virtual method means we can override it, we can change the functionality. So let's see how we have the attackable bush is doing just that basically. So we have the attackable bush here, and you can see here it is an attackable base, so it extends attackable base instead of mono behavior. And then farther down, we say override the onHit method. So whenever the onHit method is called on this bush, my method is used and not the base method. The cool part is that in the collider we are actually searching for an attackable base component, and then we're calling the onHit on it. So the attackable bush is a base component basically, because it extends the base component. So even though this method is called attackable bush and has the onHit overridden here, we are still finding it while by looking it for an attackable base component. And this is the cool part about overloading. And I actually created a YouTube video explaining this concept better and uploaded it to our channel, Let's Code Games. So you can, I think that was yesterday's video actually. Was it? Oh no, it will be on Tuesday. Yesterday's video was interacting with objects. And so on Tuesday there will be a video explaining the attackable base stuff and attackable bush stuff, actually with the interactables, just explaining the concept a little bit in a little bit more detail, more clearly. So you can look forward to that. But yeah, so we are searching for attackable bases, and then we're calling the onHit method. And since on the bush here, on the bush we have an attackable bush, which is an attackable base as well, we can attack it. So we can also create an attackable bat for the enemy now. So, well, let's call it an attackable enemy. And we can extend the attackable enemy and make use the same functionality we used before with the attackable bush. So let's make sure this extends from attackable base. And then we want to override the onHit method again. So override. Let's just copy it from the bush. So it's public override onHit. Okay, let's see what happens when we hit an enemy. So we want to, the enemy should have some properties. It should have health. So let's give it a property called max health. And then in the beginning, we want to make sure that I want to retain the max health in order to be able to heal back up. So I create a new method called health here, and then in the beginning, in the awake method, we're basically setting our health to whatever the max health is that we set up before. And since the max health is a public property, we can set it in the Unity editor, right? Okay, so our health is set to our max health in the beginning, and then when we hit onHit, we basically want to reduce our health. And let's just see a debug new health, so what the health is here. Hi Oliver, nice to meet you finally in a live stream. I love the series, it's so good and useful. Thank you. Thanks a lot. Yeah, I'm glad you're here. but yeah, either way, if you watch it on YouTube or on Twitch, either way, I'm happy that I can help and that you find it useful. All right, so let's see if this works out. Something is strange here. No, everything is fine. It's still compiling. Let's attach this to our bat prefab so that all the bats have this. Attackable enemy. So the bat is an attackable enemy and it has max health of just 1. Okay? Let's see if that works. And basically what I expect now is that when we attack, wait, I don't want to have it maximized. When we attack the bat, it basically should show in the console the new health of the bat. So it starts as 1 and then should reduce to 0 when we hit it. So let's see if that worked. And we attack it. Nothing happened. Nothing happened again. So let's see if I did something wrong somewhere. Attackable enemy is fine. It's attached to the bats. Why you cannot navigate to attackable base? Why is this? Why is this not added to my project here? This is weird. Alright, so now the enemy is okay, something messed up here. So let's have some debug values in the sword here in the weapon collider and see if we actually find this object and if we find the attackable component. Oh, I think I know what the problem is. Okay, so the character. Okay, so the problem is why nothing is happening is because the bat itself basically only has triggers. So it has a proximity trigger and it has a collision trigger. And the sword is a trigger as well. So everybody is a trigger. And then no one is triggering? That is not good. So a trigger is not triggering for another trigger. So we need well, what we can do is we can create yet another collision object for this bat here, and we call this the hit collision. And then we can make this a little bigger so it's easier to hit. So the cool part about making different colliders for all these different methods, for hitting, getting hit, or getting in the proximity zone, you can have different sizes for all of them. So this way, so the medium circle here basically would be attack zone. So if we hit the bat somewhere there, it will get attacked, it will get destroyed or hit basically. And if the character hits this inner circle, then we get hit. So this way we have the most control over what hit event is triggered and stuff like that. Alright, so let's make sure that this circle collider here is not a trigger. And then we create a new This is actually not as simple as I thought it would be. Interesting. Interesting. Okay, let's see if we at least get hit, or if we at least register a hit here. So let's put a debug log in the onTrigger enter for the weapon. So we're colliding with a collider, What's the benefit of using a collider over programming using the character's distance, since I'm assuming the bat only ever cares about colliding with the car? It's true, but then you would have to check the distance every frame yourself, and the physics engine is there to do that for you, and it has these events, so it's much more efficient if you use the physics engine properly. It's just a different way, but if you care, you can do the collision yourself as well, of course, using the distance of the characters. Yeah, I don't know, it's just a different method. So, okay, we get pushed back by this, and then we cannot hit again, but this is not good. So let's see, if we make the hit collision smaller than the collision trigger, if we can get away with doing that. Because if it's bigger, then the bat cannot, it pushes us back, and we cannot get hit by the bat. So okay, so this works. And then we got our hit collision here. Okay, so this method works. But since the hit collision does not have the attackable enemy attached to it, we won't find this component, so we have to change that. So we basically remove the attackable. Do we want to do that? Yeah, let's do that. We remove the attackable enemy from the base objects and attach it to the hit collision. No, we don't want to do that actually. This is a complicated problem. I didn't expect this to be so complicated. Alright. So we have an attackable enemy, which is fine, but we're getting the hit event in the child object. So what we can do is multiple different things. Either we put the attackable component on here on the child object, but then we have to rewrite the code, so well, we haven't written it yet, so let's go the simplest path for now. So we remove the component here, and we add this attackable enemy here, and it has a health of 1. Apply this to all and see if we can get the hit event to register and the health of the bat to drop. Okay, let's get the sword here, go over to the bat and attack it. And we're hitting the proximity trigger. Okay, so, but this works. We're still hitting our bug, but the health of the bat is being reduced here, which is good. So the bug that we're hitting right now is that we're getting pushed back while we're in our attack state. And then our on attack finished event is never triggered. So we need to make sure that we take care of that ourselves. Let's go to the movement model. And let's find the pushback. Update push time is being pushed, is frozen. What is this method called? Push character. So if we push the character, so pushing the character basically should, because we're flying back and our attack animation is cancelled, we need to make sure that if we are attacking, then we're calling on attack finished on here, and we have wait, let's go to the animation listener. What happens in on attack finished? Oh, we call this in the view as well. Oh, this is a mess. Let's think a bit. So the problem is on attack finished actually calls the model and the view and then hides the weapon. So actually a bunch of stuff is happening in on attack finished. But pushing the character back is we only know about this, at the moment at least, inside of the movement model. So we have to make sure that on attack finished is called if we move out of the attack animation prematurely as well. What size are the sprites for the character? I think they are 128 by 128. So not that big at all. Oh, this is messy. This is messy. I mean, we can actually on the spot I cannot think of a really clean method to fix this. So right now I'm going to implement a hacked method, think about this during the week, and then we can fix that better in the so we can fix it properly next week, stuff like that. So if we are attacking while being pushed, then we want to find our animation listener and then call its get component in children animation listener, character animation listener, and then call its on attack finished. This should work. What is the Visual Studio thingy that is showing your name and changes? What do you mean by name and changes? This pop-up? How can I make this get component this? You mean this thing here? On top of the methods. Oh, I'm not sure. I think this is just the Pro edition of Visual Studio. It's nothing that I added consciously. It just was there when I installed Visual Studio 13. So I'm actually not quite sure. All right, let's see if this fixed our problem. Let's get the sword. Let's move over to the bat and attack it while we are being hit. Okay, it looks promising. The sword showed for a brief second and then disappeared again. And now we have the same problem again. Oh, this is a problem when you hack stuff in. Is attacking is true. Okay, so I think another can attack basically if we're being pushed back is being pushed, then we shouldn't be able to attack. This might be another set of the problem. Whoops, let's move this out here. And then attack the enemy while it's pushing us. Okay, I think this might have fixed it. Yeah, so the problem is when we were attacking and being pushed back at the same time. Alright. So now that we can attack the enemy because it's being registered, we need to make sure that the character is actually destroyed. So for the bat, since we put this component, the attackable enemy, on the child object, we cannot just destroy the game object. We have to destroy the parent. But depending on the enemy, because we called it attackable enemy and we want to reuse it in many different parts, maybe we cannot be quite sure where it is located in the hierarchy. So let's create a public reference to the game object. Parent. So the enemy object. So basically we can destroy this object. And then we can say on hit, if health is lower than or equal to 0, we destroy the enemy object. Or we call it destroy object on death. Just so we know what it is. Okay, get the sword, attack the bat. And nothing is happening because we haven't set up the reference yet. Of course. Let's try that again. Right, let's get the bat over here, attack it, and there you go. We just killed our first enemy. Oh no. Second kill. Third kill. Oh man. So murderous here. It's getting dark. And there's actually a sword that we used earlier that we don't need anymore. Cool. Okay, so we can attack them. We can kill them, and now so something that happens in Zelda is when you attack an enemy and you hit them, you push them back a little bit, and the animation plays basically over that. So it gets pushed back a little bit, and then the death animation is being played. So let's add this. The cool part about reusing a bunch of our code, so our bat objects also have the character movement model, which already has the pushback code attached to it. So that should be very easy to implement. So let's get a character reference to our character movement model. And we get that in the awake method. And we get that in its get component in parents as well. Oh no, let's make this public, because we still don't know where it is in the hierarchy. So we set this up in the editor. So on hit, so we get hit on hit by what do we get hit? Alright, but we don't know where it is. So let's extend our onHit method to include the object, the collider that is hitting us. Collider, and item type. So we need to fix this, we need to add this in all the onHit methods. Attackable bush needs this as well, even though it doesn't need the collider. And then in on hit, we are basically also the weapon collider. Let's make sure require component type of collider to D. So this needs a collider to D, and we need a reference to that. And set up references in awake as always. And then we pass this collider along to the onHit method. Alright, so in the enemy, if we have a movement model here, we want to push the character back. And we have a push direction, which we calculate by using the center of the collider that we're hitting with in our position. So we're getting push direction, our position minus the hit collider game object position. This is the push direction. Let's make sure that the push direction, that we can set up how fast we want to push them back. So public float hit push strength and public float hit push duration. So we can, these are the two variables, how strong are we being pushed and how long are we being pushed. So the push direction is, so we normalize this first and then multiply it by the hit push strength. So it's always, so normalized times the strength means it's always the same size. And then we also pass on the duration. And then one other thing is, because this enemy only has one hit point, it gets destroyed immediately. But one parameter of destroy actually has a second parameter, and that is a time. So you can pass on a time into the destroy method, so the destroying is delayed by some time. So let's put another public parameter here, float destroy delay on death. So we can delay it a little bit. Okay. Let's go to our bat and set up all these new parameters that we now just set up. Something is... Oh, I haven't saved this one? What's going on? Ah, we need a collider to D here, of course. It's always the collider to D that I forget. Okay, let's go back to the bat, prefab, and in the hit collision, let's set all this up. So the movement model should be our parent. The destroy object on death is our parent as well. So we set this up. Destroy delay on death. Let's set this to 0.5 seconds, just the same duration as the hit push direction, and the strength is 4. Let's see what happens if we attack this now. It's probably getting pushed way too far. Yes. And not fast enough. It doesn't look as good. It should be pushed back really forcefully. It just got hit by a sword. I mean. Alright, so attack again. Better. destroy delay. And then let's also make sure that when we die, we have a movement model. Then we freeze the set frozen to true. Effect game time no. So the character, when it's dead, it's basically being pushed back, stays there, and doesn't move anymore. This way we can increase the destroy delay, and it will be pushed back, stay there a little bit, and then let's see how this looks. Let the bat fly towards us. Kill it. Oh, so the frozen. If it's frozen, then we're also not pushing back anymore. So okay, that's not what we want to do. So we don't want to freeze it then. What is... Okay. So it's the bat control. So we basically want to tell the bat controller, hey, we don't want to do anything anymore. But we can do this the other way around. Let's get a reference to the attackable enemy. And let's have a functionality in here that we can get the help. Get help. And basically in our control script that controls the movement of our bat, we're now checking if we're dead, if character is in range we want to move, and if, well, no, we make it the other way. So if we have an attackable enemy set, we cannot be sure of that if it's not 0, and the help attackable enemy get help is lower or equal to 0, then we want to set our direction to 0 again, then we don't move anymore. Basically, when we're dead, we don't move. To set up that reference, and the bat control, we get the reference to the attackable enemy. So we don't have to freeze the character, because then it's not pushing back either. Okay. Attack the bat. Yeah, that's better. It gets pushed back, it stays there a little bit, and it's destroyed. And I wanted to stay there a little bit, because now I want to add the death effect. And so I think I have to create this again. I have to create the object for this again. So let's create the object. It is called enemy death. Alright. Enemy death fx. It has a sprite renderer. It also has an animator component. And gets this enemy death. And if we press play, you can see the effect is playing. It looks pretty good. But basically we want to destroy it after the effect is over. So let's create a new frame for this when we're done here. Chop, chop, and then done. we want to set the sprite to nothing. And we also want to have an animation event, so we destroy this effect, basically. And this goes over everything, so let's add a new sorting layer, call it effects, the FX sorting layer, and put it over every object except the UI. Alright. Put it on the effects layer. And make sure that the animation is not looping, that is also important. So it's only playing once and then the effect is done. And this is how it looks, so let's press unpause here, and then the effect is done. Cool. Create a prefab from this. Oh, or we have an effects folder already. Okay, so let's put this in the effects folder. And now, in the attack enemy, we also create a new property called the death fx. And basically, if health is smaller than 0 and we have a def fx object, then we want to create it at our position. We might want to delay this as well. Public float delay def fx, and then we need to use the coroutine here. Def fx coroutine. And we could put a delay in here. So start a coroutine, and then put the delay in there as well. Wait 4 seconds, wait the delay, and then after we waited, we call instantiate def fx at our position and with no rotation. Okay. Let's put all that into the bad stuff. Attackable enemy in the hit collision stuff. Create the effects here, death of X, and then delay it by 0.2 as well, because it's the same delay size as the push duration, so it gets pushed back and then the effect is playing, or should be playing. Let's see if everything works out. Nice! That looks good. Looks really good. Cool. So now we can destroy the enemies with style. Cool, very cool. Let's kill some more bats. Play again. Maximize. Get the sword. Go to the bat. And destroy it. This looks really cool. Well, I guess this is all we need to do for the fighting the enemy. I mean, since we also want to do GUI stuff with the rubies and stuff, let's add some loot to these characters. So we have the rupees, the sprites for the rupees. Let's open that up. Nope, sprites. Items, ruby, 64. 64, and it's multiple sprites actually, so open the sprite editor and then slice it using a grid as always. I think it's 128 again. Yep, looks good. So we have the green, blue and red rubies. Let's apply this. I think we can probably make them, well, anyway. Okay, let's create a collectible item. So this is a new game object. Call it Ruby. And then just as always, we are putting a visual child object on there. I have a sprite renderer attached. Let's forget about the animation for now. I mean, oh well, or not, let's just do it. It should be simple enough. There, this is all the green rupee stuff. Ruby green animation. And then use this as the visuals object. So make sure it's actually the center, or probably where it, at the base, or probably where it lands on the floor. Yeah, this looks better. Let's see if the animation is good. Oh, I think I went too far. So I have the green ones, and then we can remove the blue ones. Just need the green ones. And the effect should actually not trigger like this, just triggers sometimes, like with a little delay. So play, play, play. Should be a little faster, and the delay should be longer. Play it. Yeah, I think like this. This is good. Alright. So we need a collider for this, as always. I think a box collider should do fine. Make it smaller, of course. Whoops. And then it's supposed to be a trigger as well. And then we need a collectible trigger for the character. So it's not an interactable, we're not interacting with it in a way, so we press E and then interact with it. It's just a collectible. So let's put this in objects. For now, we just make it collectible item. I'm not sure if we need different types later on. It will basically have an item type and an amount, and then when we collect it, we get that amount and add that to our inventory. So it has a property item type, and then it has a property amount. So we can set up which item we are collecting and how much of it. And then void on trigger enter 2D. Don't forget the 2D. Collided 2D. If the character and then we basically just check if the character has an inventory, and if so, if the character that we're colliding with has an inventory, then we want to add our stuff to the inventory. So add item, our item type, and our amount, and then we also want to destroy ourselves. Pretty simple collectible object. Whoops. Item type. Okay, add this to the rupee. So this is a collectible item. And then first of all, we need to add the rupee type in our item database. So we add this to our item types. Shield, small key, big key, and ruby. Just add this to the enums of items that we have. And then in our item database, let's just set this up properly. The rupee has a prefab. No, it hasn't yet. Let's create this prefab for it. Back to the item database. So the rupee has this prefab. It is not equipable. It will not have an animation when we pick it up. And for now, let's just re-add our debug value, adding item type, amount. So because right now the rupee would basically just disappear, so we so let's just have this debug in there so we know what if everything worked as we expected. Alright, let's move over there. Get over here. There's our rupee. And we adding rupee amount. Where's that H coming from? Yeah, but we collect the rupee, which is what we wanted to do. But I actually don't like that the trigger is here. Let's put the trigger to the full size. Okay, so we can add rupees to our inventory. Now that we have that, apply, we can make the rupee appear when the character dies. Right? So for that, let's add we can add something. So for the character, basically on destroy, we want to create a rupee And later we can even have a random value in there, so not every time a rupee is created, but yeah, for now we just create the rupee whenever a character dies. So let's do that. In order to do that, we create a new component that is solely responsible for spawning items on death. I'm not sure where I want to put it yet, so I put this into our enemies folder. Create drop item on destroy. Oh well, I'll put it in the objects folder, I think, because it's related to items. And we can also use it for other stuff, for the bushes when they get destroyed and stuff like that. So drop item on destroy. And then Unity has this magic function, just like start or update, called on destroy, that gets destroyed, that gets caught when the object, this component, is on, or when this component gets destroyed. On destroy. And then we want to say item type, which item we want to spawn. Drop item type and how much of it. And we can use our item database for that. So let's go back to our, so we have our database, item, find item, so we want to find our drop item type. Let's make sure that the data actually exists. So if there is no data for this item type, then we don't want to create anything. And then in the data, we also want to make sure, or if the data doesn't have a prefab, then we also don't want to create anything. Other than that, game object, new loot. We instantiate the prefab from the item data at the position that we at right now. And again, no rotation. So we actually don't need this part. Just create the object. So let's add this to our bats. Drop item on destroy, drop a rupee, the amount of 1. Well, the amount is not doing anything right now, but it's fine. That is fine. So let's kill an enemy and see if we get some loot. And there you go, there's our loot. It's not quite at the right position, but it's still loot. And that is because I think our rupee, the bat and the rupee, yeah, alright. Let's make sure that the pivot of the bat is actually at the bottom, so where the feet would be, where its position is. So let's move the bat up a little bit. And then we also have to make sure that we moved everything with it. So let's move this up. So the pivot of the object is actually at the feet of the character. And because I did the same for the rupee, so this way the rupee will not be created at the feet of the enemy. Let's destroy this bat. Poof. And there is our loot. Sweet, sweet, sweet loot. This is so cool. I'm really happy with this. I think we can add a small flourish here. We don't need that. Ruby. So the Ruby has an animation when it gets spawned, right? And in Zelda, it basically just jumps up a little bit and then drops back down. So we can do that very easily since we already have an animator on here, and we just have the Ruby green. We can create an animation from that. Basically we just use the animation and then, oh no, we're looping it. All right. Okay, so create Ruby green, call this bling. No. Ruby green bling, and then Ruby green spawn. Which is our new animation. Let's make sure the spawn is the default animation, and then we make a transition. It has an exit time, yes, but it has no duration, and then at 99 it goes to the Ruby green bling animation. When you just instantiate an object like you did with the loot, how can you access that afterwards? I'm asking because you don't have any variable fed into that instant of the item, right? Yeah, you're right. I don't need to access this afterwards. I just want to create this item, and then this item lives on its own. But you can, if you want to modify it here a little bit, you can basically just make sure that you save it into a variable like this. But for us, we don't need it. We just create the object, and then the object has a trigger, so it's now in the world, and when the character moves close to it, the trigger, its trigger gets triggered basically, and then this part of the code, the trigger part of the code, takes over. Okay, so we have the spawn animation. It gets over there when we're done. Let's make sure that the spawn animation is not looping, and when we select this, we can set up the spawn animation. So the bling remains as it is, and the spawn animation, basically what we want to do is we want to animate this at 2 different times, and in between it should move up. Oh, so no, I don't want to. I want to change the position. Yeah, in between the position, the sprite is not changing at all, actually. The position is, and then it should go back down. That's how this looks. And then since Unity is adding these curves, it already looks kind of okay. Let's just make it drop. So boop, and then go a little bit back up, and then back down again. Oops, no, wait, what? No, again, let's copy this over to here, and then make it a little bit drop afterwards. Alright. This is good. And then in the curves, let's go to the curves here. You can see this is our animation, and I want to change it slightly because it should bounce back down here. So let's break the tangents here and make sure it drops down hard, and then also jumps back up hard again. So it goes choop, choop. It's a little fast. Let's make this a little slower here, the drop back. Cool. And then it should this should be the resting position, and then it goes to bling. Okay. Let's see how that looks. So press play, and we get our sword, attack the enemy, and then I hope this comes over. You can see this in the stream. My computer is not always fast enough to be smooth here, but it looks really good. Cool, and then we get some loot. Awesome, so fighting the enemy and getting some loot is done. I think the last thing, I mean, we're getting close to the end of our stream for today, but the last thing that we can do is we still have some interface items. Oh, I think I haven't exported them yet, so let me quickly open up Photoshop and get this over. So Zelda 3, just see in the UI, and then we have our Ruby UI stuff. And this is basically just a slightly different looking Ruby, so you can differentiate it. This is the UI Ruby, and so you don't mix up the UI Ruby and the gameplay Rubies. So it's slightly tilted here. Let's just export this as a PNG and put this into our project folder. Oh, well, let's make sure that Photoshop is actually small enough here. Alright, this is better. Okay, so let's export this. Go to our project folder. Assets, tutorial, sprites. Interface, and then put this into the Ruby UI PNG. How long have you been developing this game? This is the 8th stream, I think. So yeah, so I'm streaming every Saturday for 2 hours, so basically 16 hours. I mean, that's wrong. Last week I did something during the week, so let's say roughly 18 to 20 hours now. It's not bad for 20 hours, right? Okay, so we already have an interface, so the canvas set up here. So where is our canvas? There's our canvas here, which is our dialog box. But we don't need the dialog box now. We create a new UI element, a new image UI element. So you see the white box here in the bottom. Let's just put this in the top left corner right now. So we attach it to the top left. The pivot should be the top left as well. And this way we can say we want to have it positioned 20 pixels away from the top left corner. Put our Ruby UI in there. It's a little big, I think. Let's make this smaller. 50. Well, I leave it. Well, I'm actually not quite sure. Let's do it like this. And then next to it, we want to have a text in here, so create a text component. make sure we're using our fonts here that we have, our medieval font. It should be white. Can we give it an outline? Component, UI, effects, outline. There you go. This is good. Maybe a 2-pixel outline. No alpha, please. And then the font size should be a little bigger as well, so we can see it. And this should be our Ruby counter. Okay, let's make the script for that. Go to scripts, interface. Let's call it UI Ruby UI item counter. We can make it extensible, so later we can use it for keys, the number of keys we have as well and stuff like that. So the UI item counter, basically we need a reference to the inventory we want to count the items in. We need the item type that we want to count, and that should be it. So our inventory and the item type. And then each frame, well, first of all, we get a reference to the, whoops. Since we're using UI stuff, we need to make sure that we set this up. So we're using Unity UI, and then we want to get a reference to the text in our awake method. Get component text, and we need to use this using Unity engine.ui because the text component is in the UI namespace. And then in each update method, we basically setting the text to, well, let's check first if the inventory is null, then we don't want to do anything. And then each frame, we're setting the text to the amount of items. Do we have that functionality already? Add item, no. We don't have the measurement. So let's get item count for item type. And since our inventory is basically a dictionary, this is very simple to do. We check if the item exists. If it doesn't exist, then we return 0, so the item count is 0. Otherwise, we just return whatever the value is in our dictionary, because we set this dictionary up in such a way that it has the key, the item type as a key, and then the amount of items we have as the value. Okay, so get item count for the item type. And I want to, so how's Zelda? I think Zelda's doing a 001, right? So you always have three numbers there. So I think let's expose this as well. So this way different text can have different formats if we want to have it that way. So for the texts, let's add the UI item counter. We're checking the Ruby type. We want to have 3 zeros at all times. And and the inventory is the one of our main character. Let's see if that worked. So we have 0 rupees right now. Let's get some monies, collect this, and then we have 1. See how easy that is? And suck. Then we have 2. And 3. And now we can kill enemies and we get loot, and we're actually counting the loot as well. That is really cool. I'm really happy with this. I mean, I think this should be a... This should be a good... stopping point, I think, for today. I mean, I can still switch a little bit. I mean, I saw a small sorting issue for the rupees here, because they're behind the tree when they should be above it. So the rupee should actually be on the same sorting layer as our character is. This way they will be in front of the tree if they're below it, and then they're behind the tree if... So they're above the tree if they would be here, and then they're below the tree if they're behind the tree if they're in the top part of the tree. I somehow have the feeling that the stream starts lagging when he starts the game. Yeah, the problem is that I'm streaming in full HD and my computer is not quite strong enough to do that. So when I also play the game, it's lagging a little bit, sadly. But yeah, I think it's not so bad on the recording. So the YouTube stream should be the YouTube video of this should be a little bit better. But yeah, we have to wait till I can get a new computer that can stream full HD video. Sorry about that. But yeah, so this is the GUI stuff that I wanted to do today. Let's strike that out. Oh man, this feels good. Striking off to-do list items. Always good stuff. And we actually finished everything we wanted to do today 10 minutes early. That is well, that's a first. But I'm really happy with what we with the progress from today. So we can get the sword. Let's get the shield as well, so we have everything that we worked on. Let's get the shield here. And well, actually, what we can do is we can add a little randomness in our loot drop here. Because I want to add it to the bushes as well, but not every bush should drop a rupee. So this is a very quick thing we can still do in the remaining 10 minutes here. So in our drop item on destroy method, we also add a property called probability, and Unity has these cool attributes that we know that the probability should always be between 0 and 1, right? So 1 if it will always spawn, 0 if it will never spawn, and everything in between for the probabilities. So Unity in Unity 4.6, I think, Unity added these property attributes, so you can define a range for this property and say this should only be between 0 and 1. And then in the editor, when you change the value, Unity actually makes sure that it stays between 0 and 1. So that's a neat trick. So on destroy, we get a random value between 0 and 1. And then if this random value is... No, wait. So if the probability is 1... Okay, so if the random value is lower or equal to our probability... Wrong, sorry. If it's bigger than our probability, then we don't want to do anything. So let's go through this. The random value is defined between 0 and 1. So 0.5 is possible, everything in between is possible. Let's assume our probability is 0.5. So 50% of the time we want to spawn the item. In the first go around, the random value might be 0.7. So 0.7 would be bigger than 0.5, which is our probability, so we don't want to do anything. In another go, the random value might be 0.2, which is lower than our probability, so it will get through and the item will get spawned. And that's basically it. And now we introduced a probability for spawning the loot. So let's make sure that the probability in our bets is always 100. And then, since we added a range here, Unity also gives us this slider, which is pretty cool. So the bet should always drop a rupee for now. But the bushes... Oh, this is a problem. We are actually not destroying the bush. We are just changing the sprite of it. Alright. Let's just add... No, I don't like that. When you say something is very easy and then it's not. Well, it is pretty easy, but I want to... Okay, so let's have let's fake this a little bit. We call a method on fake. Oh, I don't like this. This on fake destroy sounds so hacky. On let's call this message on loot drop. And then what we can do in our attackable bush, we can send a message, broadcast message on loot drop. And we say it doesn't necessarily need a receiver. But if there is a method, if there's a component with the method on loot drop on the same game object, then call this method. This is what broadcast message is doing. So this is a cool way to reuse our code here as well. Drop item on destroy. a rupee amount of 1, but the probability should be, I think every fifth bush should drop a rupee, so only 1 out of 5 is dropping a rupee. Let's see if that is working. So our bats hopefully still spawn our rupee. They do. And then there you go. Some bushes are spawning rupees and most of them don't. So our probability is working. There you go. That's what we wanted to do. You changed the name of the functions because you can't broadcast measure that onDestroy function. Yes, I can, but onDestroy has a different function. So in Unity, onDestroy always means when the object gets destroyed, and I don't want to trigger onDestroy. Actually, and this is why I created the onLootDrop. Because I don't want to call onDestroy without destroying the object. That defeats the purpose of onDestroy of the method. It's just cleaner. So imagine another Unity developer starts picking up this code and then does something in the onDestroy method, and suddenly the onDestroy method is being called without the object being destroyed. It's just messy. So onLootDrop communicates clearly that it's called differently than onDestroy. All right. Yeah, and I think that's it for today. We did we had really good progress today. So if you wait, what? Why do the rupees stay there when they get instantiated? What? What is going on? This is weird. Why do the rupees stay there when I return from play mode? This is freaky. Something is wrong here. Something is really, really wrong. So the rupees are being instantiated in the game mode, and then when I leave the play mode, they get created in the scene. There he goes. Oh, the onDestroy. That can't be right. onDestroy is being called at... Wait, what? Wait, what? When are you being called? The onDestroy is probably messing it. Yeah, that's what I'm thinking as well, but... onDestroy is being... This shouldn't happen. onDestroy is being called at editor time. This shouldn't happen at all. This should not happen. I mean, for now. So let's make sure this is only being called when application is playing. But this shouldn't happen. This seems like a bug to me. I will make a test case for this after the stream and then send this to Unity, because this should definitely not happen. It's still being called. What is going on? I mean, yes, onDestroy is definitely messing with it, I'm sure, but this is weird. This is really weird. Okay, so, but we can just use the onLootDrop. Normally everything gets reversed to before starting the game, right? Yeah, this is what I'm thinking. There's something Okay, so I just remove the onDestroy, and then when I in the I can basically use the broadcast message in the attackable enemy as well. onLootDrop, and let's see if the drop item onDestroy, in this case it should be copy component and remove it, because now we need to attach it to the same object that the attackable enemy is at. So put it here, apply this back, and now the bug should be fixed, but still the onDestroy should not be called and going back to editor mode. So yeah, rupee is dropping. I got really unlucky there with the bushes. But the rupee is dropping from the bushes, and the rupee is dropping from the... Yep, alright. But it's not being dropped when the actually is destroyed. So let's make the destroy routine. Let's make the delay ourselves so we can spawn the loot when the object actually gets destroyed. New wait for seconds, delay. And then start a coroutine here as well. Destroy routine without delay in here. In this way, the loot is being dropped at the same second, the same instant that the object gets destroyed. Let's make sure. Let's make sure that worked, and then we're done with the stream for the day. Let's attack the bat here. Yep, it works, and it drops our stuff. Cool. All right, so we have some loot. We have a UI that counts our loot up there. We have some random probability. Only some of these bushes are dropping loot. It's pretty cool. It's also shiny and nice. Awesome. I think that should be it for today. Thank you all for watching. As always, you can find all the information on Let's Code Games. I will upload everything that we did today to our Git repository, and you find the link on letscodegames.com as well. And this stream will be uploaded to YouTube tomorrow at 6 p.m. Central European Time. So I will cut it a little bit and add some music and some slate, and then we'll upload it to YouTube. Yeah, thank you very much for coming by, and let's outro with some of our music as always. And I hope to see you again next week at the same time. Okay, bye.